Hi everyone. Once again, we are here to present to you one of our technical learning materials. Today we have the cathodic protection system. And this vlog, we are about to discuss how the corrosion is eliminated for metal structures, particularly for the tanks and other storage tank. We have several methods of application for cathodic protection for buried or above ground metal structure. In today's discussion, we will focus on tank. In Saudi Aramco, the engineering standard that covers cathodic protection of vessel and tank internal is SAES-X-500. The cathodic protection of buried pipeline is SAES-X-400, which will not be discussed. If anyone from you is interested to know the pipeline cathodic protection system, just let me know in the comment section below, and I will be glad to have it in the future discussion. By the way, I'm your host, Dom, and this is my channel's Dom's TV Engineering. For those who are new in my channel, please like, subscribe, and hit the notification bell for you to get update in my upcoming vlog. Thank you all my subscribers. Please keep on supporting my channel. Let us proceed. Our objectives for today's discussion is to be able to discuss matters related to tank cathodic protection, to be able to know related standards pertaining to the materials, installation, and testing of tank cathodic protection, and to be able to share previous experiences in the construction industry. Our outlines, we have the introduction, of course, the definition of terms, design requirements. We'll discuss the material specification, especially details of installation, and some testing, and of course the related Saudi Aramco engineering standards and other industry standards. What is cathodic protection? Cathodic protection is a technique used to control the corrosion of a metal surface by making it the cathode of an electrochemical process. A simple method of protection connects the metal to be protected to a more easily corroded sacrificial metal to act as the anode. Normally, the sacrificial metal is what we call less noble metal, so that it will get corroded easily. The sacrificial metal then corrodes instead of the protected metal. For structures such as long pipelines, where passive galvanic cathodic protection is not adequate, an external direct current electrical power source is used to provide sufficient current. Let's talk about definition of terms. All the definition of related terminologies are all based on Saudi Aramco engineering standards. will go on with the installation. The installation of cathodic protection for storage tanks are different from the design. In some design, they are using suspended anodes, where anodes are being placed hanging or suspended inside the tanks. Some are deep anode, and others are anode ribbons and titanium conductor bars. The number or quantities of anodes and designs are depends in the volume or size of the tanks. And design consideration was earlier discussed in the previous segments. In my lengthy career, I am fortunate to have several experiences with these different kinds of installation of anodes, from deep anodes, suspended anodes, and anode ribbons installation. The installation for cathodic protection for ribbon type anodes of the tanks starts under the bottom of tank plate inside the tank foundation concrete ring wall. There are several numbers of titanium conductor bars and MMO anode ribbons. MMO stands for mixed metal oxide. It is installed 600 mm under the bottom tank plate. These MMO anode ribbons are also called anode cords, are laid cross with the titanium conductor bars. Its crossing section are connected by spot weld. The numbers of MMO anode ribbons and titanium conductor bars are depends in the diameter of the tank. The anode spacing is 1 meter and conductor bar spacing is 2.25 meters. The following video will show the spot welding for the MMO anode ribbons and the titanium conductor bars. The MMO anode ribbons and titanium conductor bars are backfilled with sand and top layer with sweet sand cement mixtures. We have the plan view of anodes installation. The CP cables access are through with the PVC conduit sleeve located at 180 degrees of the tank as per plan, where the transformer rectifier is located. We need to take note of the following spatial notation. This you can find in the project drawings. All dimensions are in millimeter unless otherwise noted. The spot welding is required at each crossing of each MMO ribbon anode to titanium conductor bar and titanium to titanium bar. The sweet sand and cement mixtures under tank bottom inside the foundation shall be according to 32 SAES-005. 1000 microns polyethylene liner shall be provided under tank bottom. Recommended distance of power transformer rectifier shall be 5 meters from the tank, otherwise properly designed and cable length was considered. So this is very important for electrical. We need to take note that the transformer rectifiers shall be at least 5 meters from the tank. Otherwise, it is approved. The location of corrosion probe shall be verified at the time of installation. So we need to make a final verification of the location of the corrosion probe or the coupon because we have some splicing between anode cable to titanium wire for connection to titanium bar. We need to take note of this activity. Splicing of 16 mm squared anode cable to titanium wire for connection to titanium bar shall be done properly as per approved drawings, and materials shall be of approved compression type. So we have some details of the splicing. Here is the schematic diagram. I'm sure every one of us can understand the schematic diagram. This is just to show the connection between equipment, and this will help us to identify the connection between each other. So just take a look at it and see the connection between each equipment. We have some special notation on the schematic drawing, so we need to take note of these notations so that we can apply this during installation. This is a mandatory requirements as well. All CP installation shall be according to the approved project drawing. So that means you cannot do or during the installation without pre-approved. It should be reflected in the approved drawings. Normally it is IFC drawings. Termite weld of negative and test cable from junction box to the tank at a specified location. So especially the connection of the negative and the test cable shall be specified. And the coating repair kit to be applied for termite weld connection of tank. So there is an approved coating repair kit, so we need to use that one. And the repair shall be inspected by the approved project coating inspector. For tank inside the dike wall, junction boxes shall be in the outer side of the wall. Cable markers shall be provided for all underground cable installation. This is the picture of the cable markers, and it shall be provided for all underground cable installation. This is for the pavement marking. Normally the tank is around the tank it is pavement, so normally we will use this type of cable marker. This is for the underground CP cable, so that we can easily identify that underneath that pavement there is a CP cable. By the way, for the cable testing, we are testing the positive cable or the CP cable with 18,000 volts. We are doing the holiday test using impulse holiday test detector. So I forget to tell you the test, but I just remember it. It is very important, and especially the positive cable, we are not allowed to repair it. Maybe by accidental, it's a matter of approval. We cannot do any repair. Actually, we are not accepting with the defect or with repair. That's why during the design, the length of the cable is measured already, and it is as per plan. That's why the distance of the transformer from the tank normally, or it is mandatory to be maximum 5 meters unless otherwise previously approved. So the positive cable is very important, not to make any damage or insulation defect. So for other cables like bonding cable, it is not a critical cable, but the CP cable, that's why it is already. So guys, thank you for sharing your time with me and listening to this technical presentation, or technical vlog. I am really honored to share my experiences to you, and I am sure that you learn something from it. I'm sure it will help you in the future, or will just give you some fresh refresher course regarding the cathodic protection system. And I will try to prepare also for the pipeline cathodic protection system, especially if you guys are interested with it. I will try myself to make it for you, because you know, my primary objective in this channel is to help people. I want to help people just like what they did to me. They helped me before, and I'm just trying to pay back the community. Thank you guys, and please, if you can share this blog, or if you can share my channel with your other friends to help me to promote. And I'm just trying to help, you know that. And this is if you can share, one like, another subscriber, this is a big help for me. I'm not after the money. It's a way far, but I'm just trying to help. That's why I created this channel, to help especially those future engineers or technician, or who wish to work with the electrical field. This cathodic protection is part of electrical activities, because you have the transformers, we are dealing with the cable, and we are doing cable testing. Pre-computed the length. It is already measured as per drawing, and because you cannot make any other splice unless it is mentioned in the drawing, like what we have in the splicing between the anode cable to titanium wires. So guys, we have so many things to learn or to know about cathodic protection. Just keep on reading my slide, and it will give you more understanding, especially the requirements, the design requirements, the material specification is written there. So I think that's all for today, and thank you guys. I'm your host, Doms, and always happy to serve you, and thank you so much, and God bless, and stay safe. So please, before you quit on this vlog, please like, if you are not my subscriber yet, please subscribe, and please share. That's all. I love you guys. Thank you, and bye bye.